Okay, so in problem 5, we want to compute a 90% confidence interval for the mean of a population with unknown population standard deviation, and it's given that the sample size is 30. The value of t star you would use for this interval is, okay, so for this one, since we're looking at finding t star, that means we're going to have a one sample t interval for a mean. So it's going to have this form like this. We'll have our sample mean x bar plus or minus t star times the standard deviation of the sample over the square root of the sample size. And if you want to make a 90% confidence interval, then what we're going to have to do is look for the proper t star that corresponds with the sample size of 30, but you have to have a degrees of freedom that's going to be 1 less than 30, because the degrees of freedom will be the sample size minus 1. So we're looking at the degrees of freedom of 29 that corresponds to this with a confidence interval of 90%. So we're going to look at our table. Turn to table B, and this is again in your formula packet. So we look at table B with our t star. And the bottom row here says the confidence level. So we look at the 90%. And we look for the one that corresponds to 29 degrees of freedom. And here we're going to have 1.699. So then our answer will be B. All right, problem 6. All right, here it says radio talk show host with a large audience is interested in the proportion P of adults in his listening area who think the drinking age should be lowered to 18. To find this out, he poses the following question to his listeners. Do you think that the drinking age should be reduced to 18 in light of the fact that 18-year-olds are eligible for military service? He asks listeners to phone in and vote yes if they agree the drinking age should be lowered, and no if they don't. So no if not. Of the 100 people who phoned in, 70 answered yes. Which of the following conditions for inference about proportion using a confidence interval are violated? Okay, so the issue here is that the talk show host didn't select the individuals randomly. Instead, it was a voluntary sample because people, got to choose whether or not they want to call in. And so then we could argue that this data may not be accurate or is biased because, again, maybe the type of people who would take the time and effort to call in to a radio show and give their response are probably going to be different than the average person. They probably think differently, have stronger opinions about certain issues and that sort of thing. So we know that the random sample condition is going to be violated. Now let's look at 2. The population is at least 10 times as large as sample. 100 people phoned in. That means that the population would have to be at least 1,000, and that for sure. Like we can definitely say there's 1,000 people in the population, so that's met. 3 n is so large that both n times p hat and n times 1 minus p hat are at least 10. So let's find out what p hat would be. P hat would be 70 out of 100, so it would just be 0.7. So then n times p hat would be 100 times 0.7 or 70, and n times 1 minus p hat would be 30. So both of these are at least 10. So this is met. So the only violation is going to be A. So our answer is going to be A. All right, number 7. Here we have a 90% confidence interval for the mean mu of a population, and it's computed from a random sample, and it's found to be 9 plus or minus 3. Which of the following could be the 95% confidence interval based on the sample data? Okay, so we're given a 90% confidence interval, 90% for mean mu. So our confidence interval would be our sample mean plus or minus our critical value T star times the sample standard deviation over the square root of the sample size. Now, let's see. So X bar, we know it's 9. T star times the sample standard deviation over the square root of n is originally 3, because again, this is going to be this. We have this 9 plus or minus 3. Now, if we were to change this to be a 95% confidence interval, it doesn't tell us anything else about the about the study. That it doesn't say that we're going to change the sample size. It says actually based on the same data, so n is not going to change. So what really is only going to change is the T star, because we're keeping the same data. So the standard is even the sample standard deviations are stay the same. So we have to kind of get an idea of what would happen to the T star. What would the T star do to the 90% interval to and make it into the 95% confidence interval? And we know that essentially the interval is going to get wider. All other things being equal, if you have a 90% interval and you want to change it to 95% confidence interval, the 95% confidence interval is going to be wider. Now, how much wider is the question? So we know it's going to be at least C or D. And it's not going to be A or B because they're not stay the same size, and it's definitely not going to get smaller. Now, C or D. Now, let's say why it can't be D. Because if it's D, we're saying that the margin of error, or this part, because remember that's the margin of error, we're saying that more than doubled. It went from 3 to 8, which is a huge increase. And we can show, and I go over this in a lesson, that, and you can just look at your own table with T stars, everything else all being equal. It's never going to become 2 times or nearly 3 times the size. It's not the margin of error is not going to become that much bigger. It'll become a little bigger, but not that much bigger, especially in regards to the sample data. So it's going to be C. This is the only reasonable interval that would make sense with this data and all other things being equal.